We now use the formula. Newton's forward formula is y at x is equal to, we write down y naught plus leave some space, write delta y naught plus leave some space, write delta square y naught plus leave some space, write delta cube y naught plus leave some space, write delta raised to 4 y naught plus leave some space, delta raised to 5 y naught. Now this we have to write depending upon how many columns exist. Over here all 5 columns exist, so therefore we write up to delta 5 y naught. And now we write down the formula. The formula will be p minus 0 upon 1 factorial. So p minus 0, p minus 1 upon 2 factorial. Basically whatever number you appear here comes down. P minus 0, p minus 1, p minus 2 upon 3 factorial. Then it will be p minus 0, p minus 1, p minus 2, p minus 3 upon 4 factorial. So p minus 0, p minus 1, p minus 2, p minus 3, p minus 4 upon 5 factorial. Now basically now we insert all the values. The y naught, if you observe, y naught if you observe is the first value in the table in the y column. The y naught is the first value in the y column, that is 35.4, plus p is the value which we found 1.2. So 1.2 minus 0 upon 1 factorial. Delta y naught is the first value in the delta column, which is minus 3.1. Then you have 1.2 minus 0, 1.2 minus 1 upon 2 factorial is 2 into 1 into 2, which is 2. Similarly, this 1 factorial is 1. And to delta square y naught is the first value in the delta square column, which is 0. Then you get 1.2 minus 0, 1.2 minus 1, 1.2 minus 2 upon 3 factorial is similarly 1 into 2 into 3, the answer is 6. Delta cube y naught is what? Minus 0.1, the first value in the delta cube column, which is minus 0.1. Similarly, delta 4 will be 1.2 minus 0, 1.2 minus 1, 1.2 minus 2, 1.2 minus 3, 4 factorial. If you work out this way, 1 into 2 into 3 into 4, you will get the answers 24. And delta 4 value is the answer 0.6, first value 0.6. And fifth value will be 1.2 minus 0, 1.2 minus 1, 1.2 minus 2, 1.2 minus 3, 1.2 minus 4 upon 5 factorial. You work out, you will get the answer as 120. 5 factorial answer is 120, and delta 5 value is minus 0.15. Now what you have to do is, you have to do the internal calculations. So first do the subtraction, then do multiplication, then do division. So we have left with 35.4, then we are left with 1.2 minus 0 is 1.2, 1.2 into minus 3.1 plus 1.2 into 0.2 upon 1.2 into 0.2. See, 0.2 is obtained using 1.2 minus 1, this value is 0.2. So 0.2 upon 2 into 0. Similarly, we get 1.2 into 0.2 into minus 0.8 upon 6 into See, this is minus 0.8 into minus 0.1, minus 0.1. Similarly, you proceed, you get this value as minus 1.8 because 3 is the larger number. So you get 1.2, 1.2 into 0.2 into minus 0.8 into minus 1.8 upon 24 into the value which is 0.6, and then you have the last value which is 1.2 into 1.2 into 0.2 which into minus 0.8 into minus 1.8 into minus 2.8 into minus 0.15 upon 120. Now you have to multiply the numerators, divide and add to get the answer. That working is left for you all. Now, similarly, we now solve a problem by Newton's backward method. In this method, in this problem, we have estimate the value of phi when x is 5.5. Now, the thing is, in this case also, the Newton's method works because if you observe the x values are equally spaced, the x values are equally spaced, and also if you observe that the unknown value is at the end of the series, kind of here, so therefore we have to use the Newton's backward interpolation formula. Again, to use the Newton's backward interpolation formula, we need to use the backward difference table. Backward difference table. Now, see, the backward difference table is very easy. Take x, y, which is 1, 2, 3, 4, 5, 1, 8, 27, 64, 125. Now, in backward difference table, there will be 5 more columns. The first column will be del. Unlike in the previous case of forward, it was delta. Now in the case of backward, it's del. There will be del square. There will be del cube. There will be del 4. There will be del 5. Now, the calculations are almost the same. So in the first value in del column is obtained by subtracting these two, which is 8 minus 1, which is 7. 27 minus 8, which is 19. Similar calculation will be on 37, and this will then fetch you 61. This subtraction will give you 12. This subtraction will give you 18. This subtraction will give you 24. This subtraction will give you 6. This subtraction will give you 6. This subtraction 0. In this case, if you observe that the delta 5 column, there is nothing to subtract. Therefore, the delta 5 column does not exist. So, the step 1 in Newton's backward interpolation is done. Now, we in step 2, we find out the p value. This backward interpolation formula, if you do it, x minus x1 x minus x1 minus x is the value which we interested, and the value which we interested is 5.5. So x is 5.5. The xn is the last value in x column, which is 5. Of course, x0 is the first value and x1 is the second value. If you put the first value in this table is 1 and the second value is 2. Now we insert all of them. 5.5 minus 5 upon 2 minus 1, which is 0.5 upon 1, which is 0.5. Now we use the formula for backward interpolation. The formula, if you observe, has 3 changes. Instead of minus p minus 0, we put p plus 0. Instead of delta, there is del. Instead instead of delta there is del, and instead of 0 there is n here. So we write down the formula. Phi of x is equal to phi n plus del yn plus del square yn plus this one space, right, del cube yn plus this one space del 4 yn. So in this case we are not writing the del 5 yn because if you observe that our problem does not have the del 5 column, so we are not writing it. Here it will be p plus 0 on 1 factorial, p plus 0, p plus 1 upon 2 factorial, p plus 0, p plus 1, p plus 2 upon 3 factorial, p plus 0, p plus 1, p plus 2, p plus 3 upon 4 factorial. The yn in this case is the last value in the y column. In forward we take the first value, whereas in backward we take the last value. P, if you observe, was found to be 0.5. So it's 0.5 plus 0, 1 factorial is 1, and del yn is the last value in the del column, which is 61. Similarly, we get 0.5 plus 0, 0.5 plus 1, 2 factorial is 2, del square, last value in del square column is 24. So in backward we always take the last value. This is 0.5 plus 0, 0.5 plus 1, 0.5 plus 2, del cube, the last value in del cube is 6. 6 upon 3 factorial is again 6. Similarly, we get 0.5 plus 0, 0.5 plus 1, 0.5 plus 2, 0.5 plus 3 upon 4 factorial is 24, and del 4 value was found out to be the last value in del 4 column less than the only value is 0. So now you have to do the further calculations and get the answer as done in the previous part. Now, we now move to the next method, which is the Lagrange method. Now, in Lagrange method, there are two types of formulas. One for 3 points, x0, x1, x2, y0, y1, y2, and one for 4 points, x0, x1, x2, x3, y0, y1, y2, y3. Now this Lagrange method is used, very useful, if x values are not equally spaced, They are not equally spaced. So then you use Lagrange method. Now and it depends. If 3 points are given, we will use the first formula. If 4 points are given, we use the second formula. Now, we solve a problem by Lagrange method. Find the value of phi when x is 9.5 using Lagrange method. Now, in this case, we are given, if you observe, 4 points. So, in this case, the first point is called x0. This point is called x1. This point is called x2. This point is called x3. This is called y0, y1, y2, y3. Now, in Lagrange method, unlike the Newton's method, we don't have to construct any table, nor do we have to find any p. So, in this case, we directly write down the formula. Formula is simple. Y at x, we write y0 plus y1, y2 plus y3. And then, since it ends in 3, we draw 3 brackets on top, 3 brackets down. Three brackets down. In all these brackets, we always put x minus, x minus, x minus, x minus, x minus, x minus, we took x minus, x minus, x minus, x minus x minus x minus into x minus 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 x minus. Now here, because there is y naught, we write the down part as x naught, x naught, x naught. Because there is y1 over here, we write this as x1, x1, x1. We write this as x2, x2, x2. We write this as x3, x3, x3. Now, among all these values, x0 is used. So x1, x2, x3 are not used. So we write x1, x2, x3. Among here, x1 is used. So x0, x1, x2, x3 are not yet used. x2 is used. So x0, x1, and x3 are not used. x3 is used. So x0, x1, x2 are not used. So now our job is simple. Our job is to just insert the values and get the answer. So now in this case the x is the missing value. So we write x is 9.5, the missing value 9.5, x1 is 8, 9, 10. 8, 9, 10. Now over here you all might be having some confusion saying that x values are equally spaced. Yes, but Lagrange method works in all those cases wherein x values are equally spaced at the same time when x values are not equally spaced. Yes, right now in this problem, if you observe, the x values are equally spaced, but Lagrange method is like the universal method in which works in all the cases. But Lagrange method is mostly preferred for those cases where x values are not equally spaced. But right now in the question it is clearly mentioned we have to use Lagrange, so we use the method. So we write x, the x1 value over here is 8, 9.5 minus 9, 9.5 minus 10. This is x value is what? 7. The formula is slightly changed. The formula is slightly changed. This is x0, x0, 1, 2, 3. So the x0 is here. x1, 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 0, 2, 3. This is x2, x2, x2. This is 0, 1, 3. Whereas this is x3, x3, x3. This is 0, 1, 2. Basically, the down value is always, the starting value is always x0, and then you put 1, 2, 3 like that. So x0 is what? 7 minus 8, 7 minus 8, 7 minus 9, 7 minus 10. The y0 value in this case is 3. Plus, we write 9.5 minus 7, 9.5 minus 9, 9.5 minus 10. Down we write is 8 minus 7, 8 minus 9, 8 minus 10. The next value which is found is 1. Third value we write 9.5 minus 7, 8, 10. 7, 8, 10. 9.5 minus 7, 9.5 minus 8, 9.5 minus 10. Down we write it as 9 minus 7, 9 minus 8, 9 minus 10, and we get the value as, again, by 2 is 1. Plus we get this as 9. We get 9.5 minus 7, 9.5 minus 8, 9.5 minus 9, and we come down as 10 minus 7, 10 minus 8, 10 minus 9. Now, we do the calculation and try to get the answer. So 9.5 minus 8 is 1.5. This is 0.5 and this is minus 0.5. This value over here is 0.5. This value over here is minus 0.5. This value is minus 1. This value is minus 2 because when you subtract, this value is minus 3. So down you get minus 1 into minus 2 into minus 3, and you multiply this with 3, of course, plus you get, if you observe here, this value will be 2.5, this value will be 0.5, this value will be minus 0.5. So 2.5 into 0.5 into minus 0.5, down value will be 1 minus 1, 1 minus 1 minus 2, 1 minus 1 minus 2 into 1 plus 1, 2.5, 1 point, here it will be 2.5, 1.5, 0. Minus 0.5. So 2.5, 1.5 minus 0.5 upon down will be 2, 1 minus 1, 2, 1 minus 1. Last will be 2.5, 1.5, 2.5, 1.5, 0.5 upon 3, 2, 1 into 9. 3, 2, 1 into last value is 9. Now you have to multiply and divide and get the answer.